Hello everyone and welcome to 6.7 Hyperbolic Functions. Today we're going to start by computing the integral of tan h5x. So our first step is going to be u substitution. We're going to substitute 5x and that will make our du equal to 5 dx. So now that we have our u substitution, I'm going to rewrite the integral. Our new integral should come out to be 1/5 tan h of u du. And this is going to make it easier for us to figure out what to do with that hyperbolic function of tangent. Now, based off of our knowledge of hyperbolic functions, we know that each hyperbolic function has a definition. Using these definitions makes it easier for us to solve hyperbolic functions, or in this case, our hyperbolic integral. So we know that the hyperbolic definition of tan h is sine of h over cosine of h. And that definition in this case is really going to help us out. And I'll show you in a sec why that is as I write it out. So there's our definition all written out, and now I'm going to start rewriting our integral. So now we're going to have the integral of 1/5 sine of h u over cosine h of u. And now we're going to wonder, well, how are we going to figure out this fraction with sine and cosine? Well, remember how I told you to wait a sec earlier? This is going to work out really well for us when we use u substitution. So in this case, we're going to use v and set it equal to cosine h of u. And we take the derivative of that to get our dv. That's going to come out to be sine of h u du. And that works out great because that's going to cancel out with the sine hu in the numerator of our integral. So now using our u substitution, we're going to rewrite this integral, and it's going to be a really nice one. It's going to be the integral of 1/5 1 over v dv. So now we can actually take this integral, and we know that the integral of 1 over x is equal to ln of the absolute value of x, in this case v. And then we're going to add our plus c. And now we can start plugging in our v substitution and our u substitution to get our final answer, which is going to be 1/5 ln cosine h. And we take out the absolute value because we know that cosine h is always going to be positive. We plug our 5x back in for u, and that is going to be our final answer for this first problem. Our second problem is going to be a true or false problem, and they're asking us about the derivative of the function x to the sine h of 5x power. And they've given us the derivative that they are asking is if it's true or false. So let's take the derivative ourselves to see whether or not that given derivative is correct. So I'm going to rewrite the function just so it's easier to look at. And then after looking at it, I'm going to decide to use the generalized power rule. And right now, I'm writing out that rule for reference, and then I'm going to be highlighting to show which parts of this equation are going to equal the parts shown in this general rule. This rule is saying essentially that if you have a u of x to a v of x, and you want to take the derivative of that, we can state that as that original kind of function, so in that case it's going to be the x to the sine h fx power, and then we're going to multiply that by the natural log of the ux, in this case x, and then we're going to multiply that by vx, in this case sine h of 5x, and then we're going to take the derivative of that entire thing. Now let's go ahead and take the derivative of our function using this generalized power rule. So first, our first part is going to be that u of x to the vx, which, like I said, is going to be our original function. Then we're going to multiply that by the derivative of this second part, which is going to be the ln of x multiplied by sine of h of 5x And now let's go through and just point out with our highlighter which parts of this generalized power rule equation we subbed in with our actual function. So first, like I said, we have that u of x to the vx, which is just our original function. Next we have the ln of ux, which in this case u of x is just x. And then finally our v of x is going to be that sine of h of 5x, which we see there. Next, we're going to go ahead and focus on the second part of this derivative, which is taking the derivative of ln x times sine h of 5x. And since that's multiplication, we're going to be using the power rule. So the derivative of ln x is going to be 1 over x, and then we're going to multiply that by sine of h 5x. Then we're going to add that to ln x, and then the derivative of sine h to the 5x, which we're going to use the chain rule. So first, we know that derivative of sine h is cosine h. Keep that 5x in there, and then we're going to multiply by the derivative of the inside, which is 5. Finally, we're going to simplify down this equation and get our final answer for the derivative of our function. Now that we have our derivative of this function nicely simplified, we're going to go ahead and compare it to the derivative given by our true and false question. So after looking at the two of these next to each other, we can clearly see that they are unequal and that the answer to this true and false question is false. Okay, that's 6.7. I hope you enjoyed this video and best of luck on your finals, everyone.